Tim Verbelen should be known by quite a lot of the OSGi community folks. So I make it more than short. Among others, he's working for iMinds. iMinds is part of the OSGi IoT demo, which you might have had a look at already, or I invite you to have a look later on. It's really fun, also for myself. But Tim in general is with iMinds. He's also with the University of Ghent, and he is also an invited researcher. And honestly, he was my first pick when all of the OSGi submissions had come in, because I really wanted to hear about what Ghent University is doing with IoT based on OSGi technologies. So please welcome Tim.
So thank you, Susan, for building up the pressure now. So I'm working for iMinds. iMinds is actually not a company, as some of you still might think. It's actually more a research institution. So I'm actually part iMinds, part Ghent University, and I'm doing research. We're not building products or anything, or doing real company stuff. We just do research. And I'm going to tell you about how we at Ghent University have used OSGi for Internet of Things. And of course, I will tell you what I think was the good things, but also what still is the bad and the ugly. So IoT, everybody is talking about IoT nowadays. All the companies are trying to jump out on it and build new stuff with IoT or around the Internet of Things, but mostly reminds me of these guys. Who knows these guys? Nobody? So these are the underpants gnomes from South Park. And what did these guys do? They sneak into your wardrobe and they steal your underpants, and then they take them with them. And then they caught them and they asked, why do you do this? And they said, well, it's our business plan. Phase 1, we collect underpants. Phase 2, but phase 3 is profit. And this really lets me think about the IoT space nowadays, because a lot of people say, phase 1, we connect all devices to the cloud. Phase 2, but phase 3 is definitely profit. So in this presentation, I will first go through phase 1 and say, how can we use OSGi to connect the things to the cloud? And then I will shortly say how we at Ghent University and at iMinds, we think what could be phase 2. And of course, since we're not a company, we don't care about the profit. So step 1, connecting things to the cloud. So this is also the typical manager slide. So you see all kinds of devices. You see a cloud, there's some arrow in between, and then you have some intelligence that works in the cloud. You call it big data, for example, and this is how it should work. But of course, it's not as easy as that. So first off, you probably need some kind of gateway. And why do you need a gateway? Because all these tiny sensors, they all speak different languages. They use different protocols. You have enOcean, Z-Wave, ZigBee, whatever. There are tons of them. And then once you have your gateway that connects to these devices, then you still have to connect your gateway to the cloud. And then again, there's tons of protocols to do that. You have MQTT, CoAP, lightweight M2M, and so forth and so forth. So there's tons of these that you have to take into account. So if you want to really build an IoT platform, you have to tackle all these kind of things. You have these lots of protocols, both for communicating with devices, both for commuting to the cloud. So it's really kind of messy. So how does OSGi help you with that? Well, first of all, OSGi has the power to run both on your gateway and both on your cloud infrastructure, because it has this nicely core specification that can be very well implemented in a very small, comprehensive runtime. But due to the modularity, you can also expand it with all kinds of features, like you saw in the previous presentation, to have all kinds of enterprise features and have like a very bulky server in the backend. But the nice thing is that it runs on both parts, and that makes sure that if you build a platform, on every device you can actually have the same OSGi runtime, you have the same like core services that are there, and that is really nice if you want to build some kind of IoT platform. Second of all, the modularity and the service layer from OSGi allows you to create this nice device abstraction layer. So you can create the different kind of bundles for each of the protocols. So these are nicely modularly loose components. And using the service concept, you can create a nice abstraction layer on top of it so that each device just pops up as a service. And using the OSGi service registry, you get really these dynamics that physical things have from themselves. The OSGi services have them as well. So if a thing comes online, you have a service that comes online. If things goes away or is broken, the service goes away. So you get these dynamics for free, while in another platform you have to start writing all the code, handling all these kinds of exceptions. But in OSGi, this basically comes for free. And then third of all, you have remote services. And this is, I think, the most underestimated part of the whole OSGi spec, is that you just can take a service and then have another machine, connect those two together, and just make a service call to the other machine over the internet. And you don't care about the protocol, you don't know how the bytes get there. It's just a service, and for you, it looks like the service is locally there. So for example, take co-op. You can just say, I just use remote services. I just implement it, for example, with co-op, but it might as well be REST. It might be JSON or RPC. I don't care as long as I have my service in the cloud that is representing a device at my gateway, and I can just execute the method call. Same way for MQTT. As many of you know, it's like an event broker protocol, but instead of fiddling with all the MQTT APIs and documentations, why not just use the event admin? In OSGi, we have a perfectly simple API for doing events. Just use it and then use MQTT, for example, as a backend into your, for your event admin to actually do the core distribution. But as a developer, all this complexity is hidden until the moment you just deploy your application and you just pick which one you want. You want to use MQTT, you want to use co-op, whatever. It doesn't matter, your application will just run just fine. And actually, this is something that is treated in the new RFP 177 about IoT protocols. So how can you abstract away all these IoT protocols using very simple APIs from the OSGi specification? So if you have ideas on that or feedback, just let me know. Of course, this looks very nice, but there's always a but, of course. OSGi is hard. At least that's what a lot of people tell me, and that's why I have the question mark there, because I don't think OSGi is hard, because it has very nice features, both with BND tools, for example, and declarative services, like the previous presentation showed with the nice annotations. So actually, it's not that hard. Only people, for some reason, don't know where to find the information on, or don't know how to put the bits together. So I'd like to mention here the OSGi enRoute project, which is done by Peter Kreens mainly. And it has very nice features. It actually brings together all these nice parts that are already existing in the OSGi ecosystem and brings them together in a central place with some nice documentation, some nice tutorials. So if you want to get started with OSGi, or you once started with it and you thought it was crap, check it out again. It will really be an eye-opener. It uses all these latest features. I'm not going to go too deep into that. There's our plenty presentations also from Peter, I guess, that delve into this. So check it out if you're interested, but it's really, really is a nice way of working with OSGi. So demo time, of course. What I'm going to show you is like a very small showcase that shows the concepts that I just outlined. So what we have is a kind of gateway and the cloud, and in the cloud we just have like a dashboard UI where we visualize all the things that are connected to the gateway. Now, of course, to connect these devices to the gateway, we have written our own kind of abstraction layer. It's called iMinds. It's actually a project that was going on at Ghent University about 5 or 6 years ago, so there was like no mention from IoT back in those days, but we already needed something to communicate with all kinds of devices. So that came out of there, and I basically used it inside an OSGi framework to serve as our device abstraction layer. And then we also have IOLOS, which is our framework for distributing OSGi. So I talked about IOLOS last year. So if you want to get a hold of the internals there, you can look up the presentation from last year. But basically what it does is just a remote service admin implementation together with some topology managing. So if a service comes online on your gateway and your cloud runtime is tracking this service, it will just automatically make sure that the service is implemented at the cloud side and that you can do a remote service call. And of course, we sprinkle some enRoute over it to make it all even fancier. So let me just swap to the UI. So for example, this is how it looks like. So you have this very simple UI, and you can connect all kinds of devices. For example, this is an Ocean push sensor, and you see if I push the button up or down, it's transmitted. You have these kind of temperature sensors that you can send their temperature. It also detects my integrated webcam, so I can turn it on, for example, and say, hey, here I am, hi. So it's really easy to just detect all your devices and connect those to your server wherever it may work. You can also do this kind of, it also has a simple rule engine. So for example, you can say, okay, if I have my up button and my webcam, then I want to toggle the webcam when I press the button, save. Okay, and then now if I press the button, then my camera starts recording and goes off again. So it's really easy to just integrate this with OSGi. So let me get back to the presentation. Okay, but wait. I said it was a smart home demo, but how is this smart? The only thing I can do is just like configure a rule. If I press this button, the camera goes on, but that's not really smart, right? So the problem with all these kind of rule-based systems is that although you can configure them the way you want, it's not really smart. You have to put all the intelligence, if any intelligence, in there yourself, and you always end up with use cases that you really cannot fit in any rule. For example, you have the simple rule where you have a motion sensor, and if there's motion, then the light goes on. But when you're working somewhere and you're moving a lot, then the light suddenly goes down because it says, yeah, there's no movement, for example. So you really need to throw a lot of sensors at it then, and then you can start using cameras to see if there's somebody in the room. But then, for example, sometimes you don't want the lights to go on for some kind of reason. So there's always kind of a very small case that you're not able to tweak with this single rule. And so that's kind of what we think is a phase 2 in the IoT world, is giving it real intelligence. And that's why we are developing DIAN, which stands for Distributed Artificial Neural Networks. So I don't know if you're familiar with a neural network, but what it basically does, you get some inputs and a bunch of inputs, and then you're going to layer it down some processing pipeline, where we first do some linear operation. You take the inputs and you multiply them by some weights, and then you subsequently do a nonlinear operation, like a thresholding operation, where you say if the value is bigger than this, then it's okay, and else I discard it. And by layering these together, you get like a sort of generic function approximator that you can then tune to learn actually any case that you want. So you can actually train such a thing by, for example, giving it input-output relationships that you want to achieve, and it will be able to approximate everything in between. Or you can also train it by giving it feedback, say you're doing right or you're doing wrong, and then it can update itself to put the right weights there to do especially what you want. But this is, of course, nothing new, but what we did is we actually made nice modules of this. So every layer will be a nice module, and also will be a module in OSGi. So every arrow you see is actually a service, and this allows us to also use the IOS framework to then distribute parts of this neural network on your different devices. So to illustrate this, I made a very nonsensical thing. I call it the orange machine. So what it will do is just say if something is an orange or not. So just before I left here, I took some stuff out of the closet. That's how it goes in a university. And I just put it together on a table. So the things that you see here are 2 Raspberry Pis, a B and a B+. You can see a Philips Hue lamp. You can see a USB camera. You can see a motion sensor that detects whether there's motion or not. Of course, a robot arm, because every demo needs a robot arm. And of course, you cannot see it in the picture, but this is driven using an OpenStack private cloud with some Intel Xeon machines. They are pretty powerful machines. And so what happens then is you put some fruit before the camera. The motion detector says, OK, there's motion. It triggers on the camera starts sending frames to the cloud then processes what is seen, and then it says, OK, this is a lemon, this is not good, so get rid of the lemon. Then you have to wait a bit. It says, OK, there's nothing, then the lamp will turn red again. So now we are going to give it an orange, and then the lamp will turn green and say, OK, this is good, this is an orange. So normally should go now. Exciting? There it is. So it says, OK, it's an orange. So everybody's now thinking, oh, this is horribly slow. Do I have to watch this all the time to just see if it's a lemon or an orange? It's not usable. If that's how you want to conquer the world, it's not going to work. But of course, there is one secret machine that I didn't talk about. It's the one over there. So this is an NVIDIA Jetson board. So it's an embedded GPU. And it has 192 CUDA cores. So what's so specific about this one? Well, for neural networks, you have to do a lot of operations, a lot of the same operations, because they're all multiply and additions. So you can easily parallelize that, and this is not so good. This does not work so good on a CPU, even if you have like a cloud enterprise type of infrastructure. As you saw, it didn't work that good. But with these kind of devices, you can actually get speedups that are tremendously better. So what we did then is we took part of the neural network of these modules and we migrated those to the Jetson board. And then you get this. OK, then you get this. So we do it the same again. We will put the lemon there, and then the camera is started, and then you get a very much easier feedback. In this phase, you actually have to cover it a bit with your hand, or else your hand is gone. You have to pull your hand away for the robotic arm. So it goes much faster. So to give you an idea, first we're talking 5 to 6 seconds to process a frame. Here it's less than a second. It's like 500-600 milliseconds. And of course, if you have a lot of money and a lot of energy power budget, then you can just buy a state-of-the-art GPU, and then you can do this in tens of milliseconds, for example. But the nice thing is, with OSGi, you just put your modules there, and depending on the infrastructure you got, you can just optimize it and get better performance. So this brings me to our lessons. What is the good, the bad, and the ugly? Let me start in the other direction. So what's the ugly? Well, if you have OSGi agnostic libraries, or libraries that were once written and they have no clue that OSGi existed, and especially the ones that try to solve or address issues that OSGi already solves for you. For example, I talked about the Diamond platform. It was built like 5-6 years ago, and it didn't use OSGi, but it did want to have this kind of nice modular system. So it also had its own modular system, and if you wanted to use that together with OSGi, yeah, then you end up with very ugly code, because they start doing weird stuff with class loaders, and then you have to really know well the internals of OSGi to get around and to work with that. Then what's the bad? Well, one of the bad things I note is that, especially for the specifications in the IoT space, like the device abstraction layer and the Notion services and the Z-Wave service and so on, there are not really open source implementations available that you can just use and build your application with. That's also a part of the story why I used my own kind of abstraction layer. There are also no standard interfaces to present a thing or the data that comes out of these sensors, but this is like a general issue in the IoT space nowadays. And there's also a lot of wrong use of OSGi. People that say, hey, I use OSGi, and then give you like one giant bundle. It's like, I don't think this is the way you should be using OSGi. So there are a lot of people don't really grip where it's about. But of course then, the good. To tackle that, we have now enRoute. So I encourage everyone to use it. It's OSGi as it should be as Peter Green often says to me. Of course, there's also the IoT expert group. So a lot of the issues I addressed in the IoT space are also now being tackled specifically within the OSGi specification. There's already a lot of nice work that's going on right now. You have the async event streams by Tim Ward. I think he's presenting on that tomorrow or next day. There's also work going on a much more nicer device abstraction layer. And there's the IoT protocols that I shortly mentioned. And of course, OSGi is perfectly suited for your IoT platform because it can run both on your server and your embedded device. It gives you a very nice and modular device abstraction, and it's very transparent with regarding to remote services. So check it out. So the UI that I showed is available online, so you can check it out. It's also a nice enRoute example if you want to use one. You can also check out the iOS framework if you want a distribution provider in OSGi. It's also available open source. The Diamond framework is not yet open source, but there's some info about it, and I think you can use the binaries, but the source code is not yet available. OSGi enRoute is also there, and of course, I didn't mention it yet, but Concierge is a very lightweight OSGi framework. It's also the framework that you saw running on all the embedded devices in the movie. We also have a talk on that later today, so together with Jan and Jochen, my colleagues. So if you're looking for a very nice small profile OSGi runtime, which is also open source, also check out Concierge. So do not forget to rate the session. Feedback is always appreciated, and I'm ready for some questions.
They are probably fully baffled with the presentation. Really, no questions? Okay, well.
So I have one.
Yeah.
You said that using OSGi helps you to accelerate part of your problems. How do you deal with the difference in code that you need for CUDA versus running on the CPU?
Yeah, so what we do there is we actually use the native code directive, which is very awesome also. So we, to get of course the speed up in the calculations, it's not Java code that you see there, it's always native code. And so we have native libraries that use CUDA backends. We have native code that uses a C base using OpenBLAS. And then also we have like a Java implementation, pure Java, just to have a reference, let's say, to benchmark it against. And depending on your machine you're running it, you deploy it on, you will actually get the right version from the native code. But that's of course only switching between ARM and yeah, whatever architecture we have. But to switch between CUDA and other technologies, we have different bundles that offer the same service. And due to resolving, you can, for example, you could say, okay, you could add a capability CUDA on it, or require capability, I require CUDA for this bundle, and then you could expose on your framework, this environment has CUDA, and then you can use, for example, the resolver to do it automatically. But at the moment, we just manually say, this guy has a GPU, so we deploy the bundle on it.
I have one question. At the beginning of the slides, you actually have said that OSGi is playing a role on the edge side as well as on the core side, so in the cloud as well. As you know, there is a lot of specification work going on with regard to the cloud PaaS and SaaS.
Yeah.
Is this something that iMinds in your University of Ghent is using?
Well, the iOS framework, despite only remoting a service, it also has the functionality to act as like on a cloud system. You can just say, okay, I want to spawn a new VM, then a new VM is spawned, and then it gets linked to like your cluster, and you can deploy bundles on it. So it's actually part of the whole framework. I did not stress it here because it was mainly IoT focused, but indeed, that's also part of the use cases, and I'm also working together with David on the ecosystems spec.
Okay.
Yeah, so what happens, maybe I think we still have some time, right?
Yeah.
So maybe I'll just show it using a demo. So what happens is I'll plug in an external camera. So there it is. I'll just give it a pretty name. Camera. Okay. So what happens is I have this icon here which represents a brain. So there I can say I take an input, being a camera right now, and I can select one of the neural networks that we know about. Then I create it, and then in back all the modules will be spawned, and once that's done you will get a thing representing the neural network. So I hope this works. There it is. So what happens now, if I turn on the camera, then the frames will be sent to the network. You see it becomes active, and then it starts processing the frames, and then it will show you what it thinks it sees. So if I point it at so it says carton because it sees the board. If I point it to the notebook, of course I have to see what I'm pointing to. Okay. So if I point it to my laptop, it should say, okay, it's a notebook. So this guy just sends these into the framework as events, and then you can use these events as input for your rule system to control things. So this is one simple way of working, just using it as a classifier. But of course, the next step, what we'll do is actually, yeah, it's not foolproof, of course. The next step, what it will do is really train it on to actually directly control the signals. So for example, with a robot arm, we can actually train the neural network to control the servos directly and, for example, teach it to grab stuff or to actually do stuff. Maybe like what I can also show is the neural network itself. So this is kind of a neural network UI that we also developed. So you can then see this one is deployed. So this, it's a bit too big. Can I zoom out? So this is actually how it looks like in modules. So it starts with the input, and then you have all these kinds of modules. So it's kind of, it's not just one module or two modules. It's just, it's really a whole bunch of operations that you have to do to kind of get this kind of object recognition network. So there's really a lot of computation going on to do this.
And the modules are bundled, or each module is in the same module?
Right now, they are separate services. They are not a separate bundle, but you can package them as separate bundles. So now, what we do now is we have one bundle where you give some configuration, and based on that configuration, it will bring modules online. And if you give the part of the configuration to the same module on a different runtime, then you can deploy part of the modules on A, part of modules on B, and they will be wired together automatically over the network. But you could as well, for example, package the configuration in separate bundles, and then you have like your system where each bundle has a module, for example. So you can actually do the modularity on a bundle level as well.
I think this is it. Yeah.
Did you manage to solve the problem you mentioned with the automated lightning?
Not yet.
Not yet.
But it's a very complicated problem, and also it's not a foolproof solution, of course, because with a neural network, you know that at some point it can learn it, and it will handle things correctly, but before it actually learns what you want, there's still a long way to go. So with your rule system, you know, this is what I can do, and I cannot go further. With the neural network, you know I can go further, but I have no fucking clue when it gets there, the position I want. So there's a lot of work still going on how can we speed it up to learn and train these kind of things.
Well, it looks like as if you all are waiting for your coffee break.